left off the other day. I think this is where we left off. Y'all have to, I think the one before this is pretty much, yeah, it was these things. And we talked about those. I think we talked those to death. And then it said read carefully. And I told you I wasn't going to go through that because you've heard that for the last 3 or 4 years having to do with word problems. And I told you that I think the first thing you do is find out what's to the right of the equal sign. So here is the problem. Jana purchased a copier for $2,300 and a 1-year maintenance protection plan that cost 2 cents per copy. So that means that each copy she makes, she got to multiply that by 2 cents. If Jana spends a total of $26.26 in a year, which includes blah, 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 how many number of copies did she make? All right, first of all, I'm going to take my, let me get my handy dandy do-jigger. Oh, Lord. Hold on a second. I thought I had it pulled up. There we go. All right. If you notice, the word total popped up. When you see the word total, and I'm going to put that in red, when you see the word total, that's just as good as is, okay? That means that these two things right here, somewhere there's an equal sign, all right? When you see, or sum, okay, when you see sum or total or is, somewhere there's an equal sign. And I'm going to tell you right now that I believe her equal sign is 2626 or whatever that number was. I'm going to make this small, drop this down here. Where is my PowerPoint? I'm juggling, people. Just hold on a minute. And I'm going to minimize. There we go. I'm going to put that there. I'm going to put this here. Okay. So it says right here, if Jana spends a total of 2626, total 2626 equals 2626. Okay, that's the first thing you want to take care of because you've just figured the right-hand side of the equal sign. You just figured the right-hand side of the seesaw. So that means the other side, and they're going to add something because it said and, or let's see, yeah, there it is. Jana purchased a copier for $2,300. And a 1-year maintenance protection plan, 2 cents per copy. There you go. And that is your handy dandy equation. You'll have to excuse me, I got half this on another page. All right, now I want you to solve for x. Go ahead and solve for x. So I'm going to subtract 2,300 or take it across the river. And that leaves me with 0.02x is equal to, well, that's going to be a 6. That's going to be a 2. And 26 minus 23 is 3. I'll have to bring this up. And then divide by 2, or O2. So let's take our handy dandy calculator and let's take 326 and divide by 0.02. So she's got 16,300 copies. Hold on just a second. All right, let's see. Any questions on that one? Now, also, you might want to put down on this one, I'm going to put it in a blue color. Renting a car with miles. Junior rents a car for $100 a day, plus $3 each day after a certain number of days. Okay, let's say he rents a car for 10 days for $100. Okay, and $3 for each day, and he ends up spending $250. How many days did he have the car? Okay, now the first 10 days is this one. Okay, it'll say that in the, so first 10 days is $100. And then he pays $3 per day and he spends $250. So of course, you'll get the answer of 5 or 15. I can't remember, but anyway, let's say 100, that's 150. 3 will go into 150, 50. So he had it for 50 days plus the 10, that's 60 days. Now I know that's outrageous, okay? But I'm just making up some numbers here, all right? When you see this type of question, it's either going to be with copies or with miles or with parking. John paid for 1 day, or I don't know how it's written. Oh, yeah, 1 day. 1 day of parking is $25. And for each day after 5 days, he has to pay $1 a day. Okay, that would be 25 plus $1 a day. And at the end, he spent $50. Okay, that type of analogy or that type of problem you will do with this setup. Does it look familiar? Yes. It's basically the Walmart equation. Walmart equation that I taught y'all, X plus or minus percentage X is equal to the total. Okay. So that's one type question you might have. And of course, they're going to show you how to do it here. Let's see if I can do this. There it is, 2300 plus 0.02 N is equal to 2626. And I think we got the same answer. So you should feel good about yourself. How are we doing? How was everybody's weekend?
It's pretty good.
Anything interesting? There wasn't no good golf on.
Mine was pretty good too.
Good. Any good movies?
I haven't watched many recently.
There ain't no good movies on.
I was working.
Well, if you look at my hands, I was working on a bush hog this weekend, so I got kind of grease on my fingers. So I was bush hogging. That's what we're doing right now. I'm sorry. If you're not from South Carolina or around here, bush hogging is called clipping the pastures or trimming the pastures. So that's what you call it, bush hogging. It's where you take a BA bush hog and you cut the pastures down. So that way it ain't all ugly and some of the taller weeds don't show up. But anyway, I did that, and I actually saw the biggest deer I think I've ever seen in my entire life this weekend. If I had a gun, I would have shot it right out. I would have shot the front windshield out of the tractor because that deer was so big. I think it was at least 12 or 14 points. It had to be the biggest deer I've ever seen, or in South Carolina, in Anderson. Okay, of course they grow bigger out west, but I'm gonna tell you something. That was the biggest deer I ever saw, and he jumped out in front of my tractor at he was about 25 feet in front of the tractor. And if I had a gun, I usually carry my 9mm or my 45 when I'm bush hogging so I can kill hogs because they tear up the pasture. But I didn't have it with me. But if I'd have had it, I would have took at least 2 or 3 shots. I mean, that was the biggest deer I think I've ever seen. And we saw about 50,000 rabbits and I did see a big black snake. That sucker was at least 6 foot long. And he was fat too. Okay, evidently he'd been eating a lot of field mice. And let's see, there wasn't anything worth watching on TV this weekend. So I did see where Mississippi State beat LSU, and I was like, okay, now let's talk about what you think about that quarterback. So, like they had last year, everybody said, oh, well, it's not the quarterback. Yeah. Mississippi State beat LSU. I couldn't believe that. And there was another upset. I think it was Oklahoma, wasn't it? Okay, nobody's going to talk to me. Okay, we'll go on and talk math here. Mark IV Construction Company purchased 100 acres of land to be split into 3 parcels of land. Okay, so I'm going to draw a picture here because y'all not going to talk to me. Y'all didn't do anything interesting this weekend?
No, it was quite a laid-back weekend.
Well, I'm going to tell you something. If it's anything like what's on TV, it sucks. All right, so they're going to buy 3 parcels of land. So I'm going to draw a picture. Now, don't look at the sizes. They're not equal because I doubt they'll be equal. Okay? And that's going to equal the total. So I could say blank plus blank plus blank is equal to the total. Anytime you get one of these, they're going to be blank plus blank plus blank, and that equals how many pieces of land. Okay, so let's look at the question. 3 parcels of land on which to build houses. 1 parcel of the land will be 3 times multiplication, 3 times as large as each of the other 2. Well, the other 2, since they don't have any times on them, the other 2 are going to be X. Okay? And the only other number you got is 100. So you know that's going to be on the right side of the equal sign. So that's going to be 100. And X, and X, and 3X. So 3X plus 1X plus 1X is 5X. X is equal to 20. Now you're not done because that is 1 lot. So this is 20 acres. This is 20 acres. And what is this one? That means I want y'all to interact with me. That means I want you to talk. That means you either give me the answer or say, I don't have a clue.
Don't have a clue.
All right. Well, what does this say? 3 times what?
Oh, 3 times X, so 3 times 20.
So what's 3 times 20?
60.
Or you could say, what's 100 minus 40? 60. Either one.
I see.
See it? Good. This is very popular. This is a very, very popular. Both of these questions are very popular on standardized tests, especially this one. So you might want to write it down. I mean, put a note beside it. And you can give you a second or two to write it down right there. You don't have to write Mark 5. 100 of acres of land is to be split into 3 partials. One partial, 3 times as much as the other. How many does each partial contain? 3 sentences. I'll give you a couple more seconds to write that one down. All righty. And of course, as you can see, there you go. These problems are not hard, but what happens is students just get all, I tell you what, students get all confuzzled on 2 things. Fractions, because they don't know how to do them, because they haven't been taught right, and on word problems, because they haven't been taught right. Okay, first of all word problems that are put up on a test or homework is doable. Okay, you just got to find, just like all doors unlock. But what do you have to unlock a door? You got to have the key. You got to put the information in the right order to open the door, to do the problem. Okay. What's his name is building a rectangular sandbox for his children. Oh, Father of the Year. I believe it'd be easier just to go buy one. All right. I'm not a builder. I'm not a carpenter. That's one thing I don't do too well at. All right. He's doing a rectangular box, sandbox. Now, what do we know about a rectangle? Well, we know if you add up all the sides, you have the perimeter. Side plus side plus side plus side. We also know the rectangle perimeter. Rectangle area is equal to length times width. Okay? And the perimeter is equal to side plus side plus side plus side, or 2 sides plus the other 2 sides. Okay? 2L plus 2W. Okay, we know that. This is the, let's say this is the length and this is the width. So 2L plus 2W. Okay, we know that that's the perimeters, and the area is length times width. So the common knowledge behind a rectangle are these 2 things right here: perimeter okay, and area. All right, that's common knowledge. That's what you already should know. All right, so let's go back to the equation or the question. He has 34 feet of wood. So we know that the total perimeter is equal to 34 feet. The total perimeter, all these boards added up, is equal to 34 feet. Because that's all the lumber he has. Okay? What should be the dimensions of the sandbox if he wants the length L equals 3 foot greater than? Well, I always use crisscross with greater than or less than. So I'm just going to go down here and I'm going to redraw my box because we know we want perimeter. So I'm going to redraw my box. And we know that the length of all those sides is equal to 34 feet. But the bottom part, this part right here says L is equal to 2B, you could say equal to X plus 3. So L is equal to W plus 3. And this is W right here. So now we know that perimeter 2L plus 2W is equal to 34. So 2L plus 2W is equal to 34. But L is equal to this. So I'm going to take that and highlight it. And since that's equal to L, I'm going to plug that in for L. So 2 times parentheses plus 2W is equal to 34. And I'm going to take, since I colored that pink, I'm going to write it in pink. W plus 3. All right, finish it. All of you should be able to finish that because we did all this in 6.1. Take a minute. Finish it out. I'm worried about Miss Hatton. She ain't here today. Hope she's not sick. The big debate's supposed to be tomorrow. I'm not going to say anything.
All I can say is it will be entertaining.
I'm not going to say anything. More like a massacre. Shut up. I'm not going to say anything. 2W plus 6 plus 2W is equal to 34. I'm going to half this because I want to keep it. What's 2W plus 2W? I'm sorry, W. If you're from around here, it's W. But I have to pronounce it correctly. W.
4W.
4W. Plus 6 is equal to 34. Take the 6 across the river. 4W is equal to, I have no idea, 28. So the width is 7 feet. Are we finished? No, we got to figure the length. Therefore, length is equal to 7 plus 3. The length is 10 feet. So the answer is 7 and 10. And you should feel good about yourself. Is this another popular question? Yes. Very popular question on the standardized test. It could be a garden, it could be a fence, it could be anything. But you got to know perimeter and area of a rectangle before you can do this problem. Okay, next problem. Well, go through this. There's Sandbox. There's the W plus W plus 3. You ever notice that? When you say the letter right there to yourself, you usually say W. But when you listen to somebody on TV, they'll say W. W, W, W. Kind of like Clemson. People around here, you know, how do you pronounce Clemson? And people say Clemson. But oh no, the announcers, they don't say Clemson, because then they'd be sounding like a dumb Southerner. So they say Clemson. Clemson. I've never heard it called Clemson until the last 3 or 4 years. I've never heard it called Clemson. Anybody ever heard it called Clemson before? The announcers called it that, huh?
Nope. Not until
I've always heard Clemson, and it's got a silent P in there, Clemson. But you can't say that on national TV, because then you'll sound like a redneck. So you have to say Clemson. Lord have mercy. And 7, back substitute, you get 10. Kim is selling her homemade jewelry at a craft show. Determine the cost of the necklace before tax. If the total cost of the necklace, this is the Walmart equation. Aren't y'all glad I taught y'all the Walmart equation so long ago? This is the Walmart equation. X plus or minus percentage X is equal to the total. And I'm just going to write it at the top. X plus or minus percentage X is equal to the total. And I told you that addition is taxes and tips. Remember me telling you that? Addition is taxes and tips. And what is subtraction? Discounts. So we're going to use the positive because this is a tax question. So X plus percentage X is equal to the total. Now all you have to do is read the question and figure out where everything goes, because you only got 2 numbers. Somebody tell me where the 8% goes. That's kind of a gimme question if you look at the Walmart equation. Everybody looking at it?
In the percent part.
In the percent, so I'm going to rewrite it. X plus 0.08. Okay, so that kind of knocks out the last number, doesn't it? That leaves you with 1 number, and all you have to do is decide whether it goes on the left or the right. And all you got to do is read the question. It says, determine the cost of the necklace before taxes, which is pretty much right there. Okay. If the total well, I've got total written right here out of the Walmart equation, and the equal sign means that on the right-hand side is going to be the total. So the total is to be 34.56. So x plus 0.08x is equal to 34.56. Now I'm going to add a dashed number 1 right here, because there's a 1 in front of that x. And if I don't do that, some of y'all will sit there and stare at it. Okay, why is it frozen? Oh, there it is. I'm sorry. If I don't add that little dotted 1 right there, some of y'all will sit here and stare at this problem for 30 minutes because you don't know what to do. But I put a dotted 1 there, and you'll say, oh, that's 1.08. Divide by 1.08. Divide by 1.08. And x is equal to, handy dandy calculator. Blue didn't have a calculator. Blue's Clues. And I only watched the first set of Blue's Clues with my children. We didn't watch the second one where Steve left. We didn't watch that one. That guy was awful. And my son won't even watch Blue's Clues today. He says it's not Blue's Clues anymore. What do y'all think?
Yeah, it's not the same.
It's not the same. Yep. We have old recordings of old Blue's Clues. And we like all of SpongeBob except for the last couple of years. The last couple of years of episodes were kind of dorky. Divided by 1.08. 32. So x is equal to 32. So whatever this was cost $32 before taxes. Well, golly, you've already done these questions. These are Walmart equations. You did that in 10.1. Yeah, Hubert, we did that. Great. I thought so. And that's it, folks. That's 6.3. And we've still got some time, so we're going to move on. Got 10 minutes. I can get started 15 minutes. I can get started on the next section. And that's going to be 6.4. 6.4. Why didn't it? There we go. Variation, not my favorite subject. Okay, variation. Let me go through. We're going to discuss variation before we start. I'm going to show you what variation is before we get started. Okay, everybody likes cookies, right? Let's say that you got a recipe for a dozen cookies, 24 cookies. And let's say that they're chocolate chip cookies, so you need 1 bag of chocolate chips. You need 1 cup of sugar. I'm just making this up, okay? So I don't need anybody out there. Well, Hubert, if you're going to have cookies, you need to have more than 1 cup of sugar. This is an example, people. All right, 1 cup of sugar, 1 stick of butter, 4 eggs, and 1 cup of flour. Okay, I made it pretty generic, okay? There's my recipe. And it makes 24 cookies. Okay, in the directions, it tells you to use a small watermelon scooper, like a ice cream scooper, and scoop it up and flatten it and put it on the cookie sheet. And that makes 24 cookies. Okay. What if I wanted to make 48 cookies? That means I want y'all to talk.
Wait, can you say that one
Double
more
the
time?
recipe.
What'd you say, Miss Cersei?
Double the recipe.
How'd you get double?
24 times 2.
Say again?
24 times 2.
Exactly. You found a number that, well, the answer, you can use multiply by 2, it's the same thing. But I took 48 and divide by 24, and that gives me 2. And that's what Miss Cersei said, you're going to double. But that's where the double comes from. The double comes from 48 divided by 24. So this number, the desired number, over what it will make. So that'll give me 2 bags of chocolate chips, 2 cups of sugar, 2 sticks of butter, 8 eggs, and 2 cups of flour. Let's say I'm weird, okay? And let's say that I want to make 65 cookies. How do I do it now? You just make 72 and you eat how many? Freaking 7 cookies? No, that's not the way we do it. And I'm trying to get a point across here, so just bear with me. Anybody want to take a stab at it? Take a stab? Anybody want to take a stab at it?
Divide by 24.
Exactly. That's exactly. Good gracious, I'm just so happy. Take 65 and divide it by 24. So I'm going to take my handy-dandy calculator, and I'm going to take 65, and I'm going to divide by 24. And I get 2.71. So I'm going to multiply all my so that's going to be 2.71 bags, 2.71 cups of sugar, 2.71 sticks of butter, and then 2.71 times 4, 10.8, and of course there is no such thing as 10.8 eggs, so it'd be 11, and 2.71 cups of flour. Now, of course, 2.71 is close to 2.75, which is 2 3/4 cups of whatever. 2.75, 2.75, and 2.75. So you would use 2 3/4 cups of flour, 2 3/4 sticks of butter, 2 3/4 cup of sugar, 2 3/4 chocolate chips, and 11 eggs. Now, what did I just do? I want you to take your highlighter out, and I want you to highlight what we did right here and right here. What did we just do there? You calculated a multiplier. And what does the multiplier do? It increases your ingredients. I calculated a multiplier when I calculated the 2 and when I calculated the 2.71. I calculated a multiplier. Does anybody know what the word for a multiplier is? The word for a multiplier is a constant. The word for multiplier is constant, a constant. Something, a number that you multiply by to get the numbers to work out. I only had a recipe that made 2 dozen cookies. How do I make 2 dozen or 4 dozen cookies? Well, that is 48 divided by 24. That's twice as much. So I'm going to double everything. You just didn't wake up. Miss Cersei, did you wake up one morning when you were a little child and just say, okay, well, if I'm going to make 24 cookies and then if I'm going to make 48, I got to double it. Did you just know that one morning, or did you have to actually go through mathematics before you understood that?
I had to learn math.
Exactly. So you had to calculate that 2 before you realized that it was double. So before you learned mathematics, you had to create this 2 right here in order to double it. Here, you multiply by 2.71. So the 2 is the constant with this group, and the 2.71 is the constant with this group. Now, what does that have to do with this variation? Variation is all revolved around the constant K. That's lowercase k. Okay, and these problems, you're going to find what K is. You're going to plug it back in, and then you're going to use it. The variable in this section K, the variable does not change. You will see us change X and Y and Q and R, and you'll see us change those according to the question. But you will not change K. K will stay the same. What else do you need to know about these type questions? One, they're going to ask you to plug and chug. And that's it. They're not going to ask you to do anything else. Second type question is plug and chug, and then they ask you to solve for K. And then the third type question is plug and chug and solve for K, and then plug back into equation. And then, of course, the last one is all of that, and then they give you new information to plug in. So that's the 4 type questions you'll be asked. And I'm going to just show you an example of one on the slides. Well, before we do that, let's go over the 3 types of equations we're going to use, and then we'll stop there. There's three types of equations that we're going to use for this section. One's called direct, one's called inverse, and one's called joint. Direct variation, inverse variation, and joint variation. The question will tell you what to use. All you have to know is what each one is. Y is equal to K times X. That's direct variation. Inverse variation, Y is equal to K over X. And joint, Y is equal to K X Z. Some people put KXW, some people put KXC. It doesn't really matter. The K doesn't change. And when you change these other variables, they're interchangeable, but the K is not. And I'm going to highlight that K because everything revolves around that K. And you don't change the letter K. It stays K no matter what you do to the other variables. Okay, we're going to shut her down on that one because I ain't got enough time to actually go into examples. So we're going to shut her down. Somebody needs to make a note that we stopped at this is the introduction of variation, the different equations. So if you go to the PowerPoint, there's the first one. Let's see, where'd the first one go? There's the first one. Okay. Excuse me. Corona. They're doing it individually, so we'll just have to do them individually. All right, so we go stop right there. Excuse me. Yawn and a sneeze. Does Corona make you yawn? Y'all don't talk to me, so that's okay.
It's a new symptom.
Oh, it is? I must have the Black Plague. I need to get me a mask. Let's go with, because the mask will solve the problem, right? I think it will. Let's go and hit that.
That's what they want you to believe.
Oh, hush your mouth, Miss Cersei.